Assalamualaikum, dear students. Welcome to our favorite podcast, Beneath the Surface, where we explore the science beneath our structure. Today's episode covers a field test which is related to the soil investigation and the foundation, plate load test, and how it explains us to tackle the real construction scenario. Our team members and our guests will explain it. Before I begin, I am deeply honored to introduce our special guest, a guiding light for many young engineers, a brilliant academic record, and expert of geotechnical engineering, Sir C.L. Pearson. Thank you so much, sir, for your time.
Thank you so much, Rishi, for the honor to be part of this discussion. I'm very honored. Thank you so much.
And now, let me proudly introduce our team member. First, Narakat Ali, a brilliant student who has deep interest in geotechnical engineering and the behavior of soil. Then we have Mr. Shakil, a curious and very expert in the foundation design.
Thank you so much, Philip. It's my pleasure to be here.
Thank you. And next we have Mr. Zaid, a practical thinker with a strong grasp of foundation design properties.
Thank you so much, Philip. It is really to be honored to be here and looking forward for the discussion.
I am Ali, your host for today, and we will discuss about the plate load test and the behavior. And first we discuss the related issue which we have faced recently in Karachi, and further we discuss it about. Let's start with the problem which is recently happened in Karachi. I will hand over to the mic our guest, Shakil. Kindly brief us.
Sure, Philip. A few months ago, EHA Karachi faced a development plan to build a large building. But when the site engineers inspected the soil, they found it was mostly soft clay mixed soil. So that's why there were concerns about the differential settlement and foundation failure, especially this was a multi-story building. So the question is the soil enough to support such a structure? That's why the plate load test used to evaluate the bearing capacity and settlement of the soil.
A classical challenge, soft soil in the coastal area. To explain how engineers respond to this, I now invite our esteemed guest, Sir C.L. Pearson, to explain the plate load test and how it helped us in this scenario.
Thank you so much, Mr. Ali. So basically, a plate load test is a very simple yet powerful technique used in the field to calculate or to measure the bearing capacity and the settlement of soil. In case of Karachi, for example, we used a 50 to 75 centimeter steel plate, 50 to 75 centimeter diameter steel plate basically, which was placed on the location on which we were basically planning or designing the foundation. And then we applied a hydraulic jack. And through that hydraulic jack, the load was loaded in different steps. And through the steps, we observed how much the soil basically sank. And that sinking sand, that millimeters or that height of the soil which settled is used to calculate the settlement of the soil and the bearing capacity. So a very simple and very important test, plate load test. And it is used in the field nowadays really well.
So, actually, my question is that, so is this test new or has it been used for a long time?
Okay, so basically the plate load test has been being used for a long time right now, in fact centuries. In fact, something really fun about you is that the father of soil mechanics, Karl Perzati, he was born in 1883 and he passed away in 1963. So the father of soil mechanics, the person who is affiliated with the most research in the geotechnical environment, that person basically has died like 100 years ago or so. So you can see that geotechnical engineering formally is a very new field in terms of proper formal research, or else all the construction that happening in the last hundreds and thousands of years is always getting techniques. Similarly, the plate load test, the steps which we seduced with the hydraulic jack and with the steel plates, that is being used for 100 or so years, and it's a really, really important test as we have seen, especially in cases where we want to design a shallow foundation, because values of this test are used to formulate the bearing capacity and the settlement, based on which we analyze and we design the best suited foundation for us.
Sir, what was the result of test at the Karachi site?
Okay, so basically the results at the Karachi site showed that the soil has a very low bearing capacity and the strength of the soil is hence less. Hence, we have to recommend a foundation which is able to bear the foundation load because the soil was not strong enough to bear the entire structure. Hence, we recommended a raft foundation or a mat foundation, which is the prime example of a shallow foundation which is being used all over Pakistan and even in the world in cases where the soil has a very low bearing capacity and we need to design a foundation in the upper layer or the shallow layer of the soil and depth of 1 meter, 2 meter or so. And other than that, in case of Karachi, other than recommending a raft foundation or a shallow foundation, we also recommended some compaction techniques or some soil improvement techniques so that the soil can be enhanced in strength. Example of that would be geotextiles, some other form of polymers, or even in some cases we also use a high form of compaction, which will increase the strength of the soil. And this saved the project or the entire project from massive disasters such as settlement or such as cracking, such as other form of disasters, which can be really, really, really fatal for the entire project. I guess that answers your question.
Sir, have you faced any such case where ignoring these tests led to damage?
Oh, that's a brilliant question. I actually remember this case. In fact, I was involved in it now. A similar case I saw in Hyderabad, where they developed a warehouse and they did not conduct any form of foundation testing, such as the plate load test or any other test. And after the construction of a warehouse, as we are all aware, warehouses are used for storing stuff. So when they were storing high heavy machinery or high water stuff, the soil had actually settled. The entire warehouse collapsed. The walls were seeing major cracks, and in such a case, the warehouse was a big fatal disaster. We were glad that we did not see any human disaster, but everything being stored in the warehouse was a big loss. So that's the best example because after the disaster, when we did the testing of the soil to see what happened, we saw that the soil in that location had a very, very low bearing capacity. And while they had been given, isolated footings or the isolated footings in the soil, the best footing or the best foundation for that soil was a raft foundation. But since they did not do any plate load test or they did not do any foundation test for the soil, they did not know what was the best foundation or what was the soil bearing capacity of the soil, which led to a massive disaster. Which shows this is a very, very important test which must be used in the field.
That's a strong example, sir. It's very important to test before the construction. Now, before we warm up, let's go around and hear a short takeaway or a message from each member. Sir.
Yes, sure. I think soil testing is not optional. It's essential. Without it, we are building blindly.
Absolutely good. Sir, would you like to add?
Yeah, as we all know that knowing your ground means protecting your structure, and whether it's small or a house, testing the soil first and building it.
Okay, good. Zagat, what would you like to add?
So, the plate load test turns assumptions into data. Tests for field work.
Sir, what will your ending remark related to our podcast?
First of all, this was a very brilliant podcast and a very great discussion for which I must appreciate all of you for sitting here and doing this discussion. In addition to that, I would, however, say this to all civil engineers and all future students that when you're doing civil engineering as part of your degree, 60 to 70% courses will be related to structures and we have paving, and a very small portion is focused on geotechnical engineering. However, if you ask me as a student, as an academic, as an expert, I really must say this, that for me, geotechnical engineering is actually the basis of the entire civil engineering. As a structural engineer, when you're designing something, or when you're building an entire building, or even a skyscraper, what would the designer say? That we must pass on the load to the ground. Whatever they are planning is on the fact that the ground can bear the load. Their assumption, their belief, their entire standard is that make sure that the building's load is transferred to the ground, be it from the column, be it from the slab or anything. The entire goal and objective is send it to the ground. If you're a pavement engineer or a transportation engineer, their entire goal is that make sure that the soil beneath is receiving all the load from the transportation devices, from the roads, from the trucks, from everything. So if you're in any part of the civil engineering, what they're doing is they are believing the fact that the soil, the ground is taking all the load. Who is worried about the soil? Who is working on the ground? we geotechnical engineers. So it won't be wrong to say that geotechnical engineers are the basis of civil engineering. Geotechnical engineering is the foundation. There's a reason we call it the foundation, because it is the foundation of civil engineering. If you design the foundation correctly, if you know how to calculate the variation aspect of the soil correctly, if you know how much the soil settles, you are able to design it appropriately, and that is how the entire building is going to sustain or stand. This is the first step toward construction. When you're constructing something, the first thing any construction person will do is say, go to the geotechnical department and do the soil testing. So the first step to build anything, to create anything, is geotechnical engineering. This is the first step. If anything goes wrong, the first thing they'll do is check if the geotechnical report was correct. So this is the basis based on which everything is standing in civil engineering. So, be it the plate load test or be any form of test in geotechnical engineering, field tests, lab tests, in situ soil tests, all of them are very important, because geotechnical engineering itself, foundation design, is a very important aspect which we as students must focus on. So I would like to say this at the end, that make sure you take this subject and this part of your degree and overall this very seriously, be it the plate load test, be it foundation design, be it basic capacity calculations, be it settlement analysis, be it soil mechanics 1 or 2, take it very seriously. And on that note, even at the end, I would like to end with a poetry and a share, because I really like poetry, and it is somewhat related to soil as well. The share is that मिटा दे अपनी हस्ती को अगर कुछ मर्तबा चाहे, मिटा दे अपनी हस्ती को अगर कुछ मर्तबा चाहे, कि दाना खाक में मिलके गुलो गुलजार होता है, कि दाना खाक में मिलके गुलो गुलजार होता है. Thank you so much.
Thank you, sir. It was a powerful message to our listeners. A beautiful building is not built from the top down, but from the ground up. Without the strong soil support, even the best design can fail. Thank you so much for your time and your discussion. Also thankful to the rest of the members, Abdul Asif and Mahad Arslan, who has arranged the whole setup for us. Until next time, this is Beneath the Surface signing off. Allah Hafiz.